Chapter 1.3, Evaluating Limits Analytically. Now, the first thing you want to do whenever you're evaluating limits is just plug in the number that the limit is approaching. So for this question right here, limit as x approaches 2 of 1 over x, just plug in 2 for x, 1/2 is your answer. For this, limit as x approaches 0 of 3x minus 2 to the 4th. Once again, you can just plug in the value that x is approaching and then solve. Negative 2 to the 4th, 16. Pretty easy. Now, when it gets difficult is when direct substitution does not work. Like if I were to plug in negative 1 into this equation, I would get 0 over 0, and we do not want 0 over 0. So what we're going to have to do some algebra, move some numbers around, cancel out some terms, so that we can get rid of that 0 over 0 issue when we substitute in. So we're gonna factor this the numerator of this fraction. So the limit as x approaches negative 1 of this factors into x plus 1, x minus 1, all over x plus 1. And then now you can see that this term cancels out. The x plus 1's cancel, and we're left with the limit as x approaches negative 1 is x minus 1. Now we can plug in without any issues. So negative 1 minus 1, which is negative 2. Same thing with this problem over here. If we plug directly in, we run into an issue with the 0 in the denominator. So we're going to have to factor again. So the limit as x approaches negative 2, this ends up factoring into x plus 2, 3x minus 1, all over x plus 2. Once again, we can see that this term will cancel, leaving us with the limit as x approaches negative 2 of 3x minus 1. Now we can plug in without having any issues. 3 times negative 2 minus 1, which is negative 6 minus 1, negative 7. Now, when you want to run into a problem like this, whenever you see a radical, what you want to do is rationalize. And how you do that, all you have to do is multiply by the conjugate. So if we want to get rid of this radical right here, we're going to multiply by its conjugate, which is root x plus 1 plus 2 over root x plus 1 plus 2. And you have to multiply by 1, or else you'll be changing this expression. You'll be changing the value. So if you multiply by 1, it's fine. So you have to put it over itself. So you end up multiplying by 1. So when you multiply it out, end up with the limit as x approaches 3 of x plus 1 minus 4 over x plus 3, or sorry, x minus 3. X minus 3. All of that is times root x plus 1 plus 2. Now we'll just simplify the numerator. The limit as x approaches 3 of this ends up being x minus 3. X minus 3 times root x plus 1 plus 2. Now once again we see that these terms will cancel. Leaves us with the limit as x approaches 3 of 1 over root x plus 1 plus 2. Now we can substitute in without having any issues. 1 over root 3 plus 1 plus 2, which is 1 over root 4 plus 2, which is 1/4. Now, when you get to problems with limits and trig functions, we know that the limit as x approaches 0 of sine x over x is equal to 1. So, as long as these two are the same, this could be 3x and 3x, doesn't matter, as long as these two are the same, then it will always equal 1. So how can we get this x to have a 3 in front of it? Well, we can use the properties of limits to help us do that. So let's multiply by 1 again. This time we're going to multiply by 3 over 3. But the properties of limits say that we can take out a leading coefficient when we multiply by 3. We can take out that leading coefficient and put it in front of the limit. So we're going to end up with 3 times the limit as x approaches 0 of sine of 3x all over 3x, because we multiplied on the denominator as well. So we know that this is 1. This whole thing ends up being 1. So 3 times 1 is just 3. Now we'll move over to this side. Same concept. We want to get this x and this x to be exactly the same. So how are we going to do that? We're going to multiply by the cube root of x squared. So end up with the limit as x approaches 0 of, we're going to take this, bring it to the outside, cube root of x squared, and then this ends up being cube root of x cubed, which just reduces down to x, so sine x over the cube root of x cubed, so the cube root of x squared times the limit as x approaches 0 of sine x over x. And we know that this is 1, so the cube root of x squared times 1 is equal to the cube root of x squared.